8.2 reciprocal function family. The new stuff. Good stuff. Yeah, man, that's the good stuff. This is what a reciprocal function family looks like, the actual graph. We have a curve here, we have a curve here. With this, and it will change depending on what we're going to be graphing once we get into the tough stuff, but we have asymptotes. We have an x-asymptote vertical and a y-asymptote horizontal. And once you find those asymptotes, there's a curve within them. This is the parent function, so it's usually in the positive, positive, negative, negative. However, if it's flipped, that will change it. If it moves up or down, that could change it. If it moves left or right, that can change it. So that's kind of what we're starting with, just what the functions look like. So this first question, to identify the x and y intercepts the asymptotes of the graph. Now one thing in this function, right here, if there's no number with the x, remember the number with the x moves the graph left and right. If there's no number here, I have an asymptote at x equals 0. Asymptote x equals 0. And because x is an asymptote, meaning that x can never be 0, there's no way that this equation will ever become 0. Never. Because there's no number I can plug in to make my output 0 because of this 8 up here. So I also have an asymptote at y equals 0. So here's my asymptote x equals 0. Here's my asymptote y equals 0. And then you can always use your table function or your y equals function. But first, when I'm looking at my x and y intercepts, now x-intercept means that y is 0. Well, we already said it can't be that. And y-intercept is when x is 0. Oh, can't do that. So we actually don't have any intercepts for this graph in particular. So this is where I would plug this into your graphing calculator, get to your table, and the more points the better, but as long as I can see the shape of the curve and they're in the correct quadrants, that's okay. So here's my table, and if I'm going to graph this, it looks like this. Wham bam, thank you ma'am. And that's all we got for that first one. Now it also says state the domain and range. Now with these asymptotes, that's what changes our domain and range. So our domain, it can be all real numbers except that asymptote. So x cannot equal 0. And my range, it can be all real numbers except that asymptote. So y cannot equal 0. Again, it's how far left does it go? This makes it go on forever to the left, and the other one makes it go on forever to the right. How far down does it go? Forever, and up forever. So besides those asymptotes. So you should try to graph B by yourself. So those two curves, those are what we call branches. There's always two branches when we have a basic reciprocal family with the 1 over x, when it's the x on the bottom. Again, this is where I talked about it at the beginning. If we have a value on top, that will stretch it. If it's going to be a larger number, then it's going to be a stretch. If it's a smaller number, then it's going to be a shrink. Any number with the x moves it up, left, and right. So that would move the asymptote left and right. Any number outside moves it up and down. Those transformations are the same transformations that you've been dealing with for all of eternity. Really starting with chapter 5 with the quadrilaterals. So now I'm going to start graphing this. First thing that I'm looking at, zoom in a little bit, is I'm going to state the transformation. So this is moving to the left, whoopsie daisy, to the left 1 and down 2. That's going to change my asymptotes. So my asymptotes, that's y is backwards, but you get the gist, would be at x equals -1 because it moves left 1, and y equals -2 because it moves down 2. So now because of that, I do have an x and y intercept, unlike the other one, because we don't have those restrictions. So my x-intercept is when y is 0. So you use your function x plus 1 minus 2, plug 0 in for y. First thing I'm going to do is going to add over that 2. So I have 1 over x plus 1 is going to be equal to 2. You want to get rid of this division. You're dividing by this whole thing, so you want to multiply by that whole thing on the other side. So I can actually rewrite the equation so it looks, so it's x plus 2, and I'm going to subtract the 2 there, so I get -1 because I'm subtracting the 2, 2x, divide by 2, and I get x is equal to negative 1/2. So that is going to be my x-intercept. And you do the same thing, except now you're plugging 0 in for x. So again, same equation, but you plug 0 in for x, plus 1 minus 2. And you simplify. You want to simplify that fraction first. So that's going to be 1, because 0 plus 1 is 1, and then that whole thing, minus 2, would give me a negative 1. So I have a x-intercept at negative 1/2 and a y-intercept at negative 1. So I plot all this information, the asymptotes and my intercepts, that will help me graph. Or else you can also make your table to help you make sure you have the correct curve. So that's what your graph kind of looks like. And you don't have to write out your table, as I did. I just use the graphing calculator. But you can use a graphing calculator. Now sometimes the curves, the branches, will become closer to the asymptotes. This is that case, especially if you don't have a stretch like over here. But sometimes the curves might go really wide. Now if it's a really wide curve and you draw it like this, that will be incorrect. So make sure that you do know some points to help you with the direction with the branches. Now you should try B by yourself. This next one gives us the actual graph, and we have to decide what's the equation. Now it already gives us the parent function, and technically the parent function is the 2, a stretch of 2 with the x. Now if I look at this, first it's counted by 2s. You always have to be aware of what you're counting by. Each box is worth 2. I'm moving left 3, because that's right in the middle here. I'm moving up 4. So in your equation, 2 doesn't change. But the number with the x moves left and right. Now if it moves left, remember that's always opposite, so that would be a plus 3. Up and down is the outside, typically, of the parent functions in this case, and the outside are not in the fraction, so that would be plus 4. You should try to do the next one by yourself. Here we have a rowing club. That'd be pretty sweet if we had a rowing club. It's really good for the shoulders, and if I could name my muscles like I used to, I'd be able to name more. 57-passenger bus for a day trip. It costs $750. 5 of the people will be chaperones. The students attend share the bus costs. What function models the cost? So we have C students, and they're $750, and we have to divide it by how many number of students we have. So students, not the actual total people riding the bus. So one thing that we have to be aware about is that 5 chaperones. So we could have a maximum of 52 students. I wonder if you can hear my child screaming at me. 52 students. So my question is saying, how many people do we have to get on that bus so the students have to pay no more than $20? So this is my equation, the 750 divided by number of students. We don't want to have this pay no more than $20. So less than or equal to 20. So I want to get rid of this division. Opposite of division would be multiply. So 750 has to be greater than or equal to 20. And now I want to get rid of that multiplication. Opposite of multiplying is dividing. So that would be about 37.5 students. Well, you can't have a 0.5 of a student, so you need 38 students. In this case, you always have to round up, or else it wouldn't make, or we would have be over $20 per student. I want you to try B, that has a AB, by yourself. You have a wonderful, fantastic, supercalifragilisticexpialidocious day.